Hello everyone. Today we are going to solve today's problem of the day, and the question is minimum time to make the rope colorful. So let us walk through the example. So here we have been supplied with a string which has colors in it, and this is a zero based indexed string. And likewise, for example, we are having this A, B, A and C, and the needed times in order to remove a balloon is given in this array. So for example, in order to remove A, I'm going to invest this unit of time. In order to remove B, I'm going to use this unit of time for this A and for this. So this is just the mapping which we have been provided in the question. So we need to make the rope colorful, and by colorful, let us see the question. The colorful condition states that we need to have two consecutive balloons to be of different color throughout. In order to make the rope colorful, whenever we are encountering two same balloons, I need to remove one of them, and I need to minimize this time in order to make the color full rope. In this example, as you can see, all the three balloons are of different colors, so 0 units of time is required to make this rope colorful. This seems to be an interesting example, and so the needed times are 1, 2, 3, 4 and 1. So let us walk through this. So I am having A, A, B, A and A, and the needed times are 1, 2, 3, 4, 1. So we are going to iterate through the array so that the algorithm gets stick right into our mind. And for the first index, if I'm considering this element, the first element, this in itself is a colorful rope, so I do not need to burst it. So I move to my next element. So when I move to my next element, I compare the element at this and previous. So I'll say, okay, my previous and current. So this is the previous and this is the current. So my previous and current are same, so I need to burst one of them. And on inspection, I can say that I need to burst this balloon. So I'm going to burst this one. And the cost or the minimum time which is associated, which was initialized with 0, now it increases to 1. In the next iteration, when my current is here and my when my previous is pointing to this, wait, yeah. So when this is the case, when my current is this and previous is this, these both are different. So in that case, I need not burst any of the balloon, and I'm going to simply move my iterators to next and next. Again, I can see that my current and previous are not equal, so I'm going to move my iterators accordingly. So during the last inspection, I have see I have to see that okay, my current and previous are now equal, so I have to burst one of these balloons. So I'll choose this one greedily in order to minimize my cost, and my cost is now 2. So 2 is the output of this question. So I'll just we are just going to develop the code so that what I'm trying to communicate is clearly uh, understandable. So I'm having my cost initialized with 0. This is the initial cost which needs to be minimized. Alright. And next I'm going to have this previous, which indicates the previous balloon's associated cost or the previous balloon's associated needed time. So this I'm going to initialize with needed time 0. I've also checked the constraints that this is not of the size 0 at any instance, so this does not run out of bound. I'm going to iterate from I equal to 1 to colors dot size and I plus plus. If my colors at I is equals to colors at I minus 1, this means same color, so burst the minimum. So my cost is getting incremented by the minimum of needed time and the previous. Previous is storing the cost of the, I'll just write it here. Previous stores the cost of the previous balloon. And by previous balloon's cost, I need to mean the needed time. As well as now I'm going to update this by previous needed time I. Else this means that I'm having different colors, so my previous is now going to simply initialize with this one. At last I'm going to return this cost. Let us check for the sample test cases. So yeah, I'm able to pass the test cases, and so this was the solution. One thing which I wanted to emphasize here, this statement, the 10th statement. Previous is storing the maximum cost of the previous iterated balloons, and if at any point I'm having the same color balloons, my previous is storing the maximum of previous and the needed time. So for example, if I'm having this scenario, let us say this is 1 6 uh, 5 and 1. So it is pretty sure that we need to remove this, this and this. So while I start from this, I'll say okay, one of these needs to be burst. So I'll burst this one. Then my iterator goes to this, and I'll say okay, these two are equal, and my previous is retaining the maximum. So here the maximum is 6. Okay, so here the minimum is going to be my 5. Okay, so cost is going to include this one, and the previous is already being set to 6, and at the last element I'm going to compare this and this. So here also I can see that in cost the minimum needed time will be included, so I'm going to include this, and my previous uh, gets pointed to here itself only. And at last I'm going to add 1 plus 5 plus 6, 1 plus 5 plus 1, which is going to be 7. So this was the algorithm behind the question. Thank you so much.